good morning, everyone, wherever you are in the world, and welcome to today's webinar on enhancing energy efficiency in data centers, key strategies and innovations. My name is Clara Camarasa. I'm a senior advisor at UNEP CCC in the Copenhagen Center on Energy Efficiency, and I'm delighted to be your moderator in this session. So as you all know, data centers are the backbone of our digital economy, from hosting critical businesses applications to enabling the streaming of services and cloud storage. Data centers are really at the heart of nearly every aspect of our modern life. However, the rapid growth has also brought with it significant environmental challenges. With increasing energy demands driven by the proliferation of AI, machine learning, and other data-intensive applications, the pressure is mounting to find the sustainable solutions for this sector. This is why energy efficiency comes in, not just as a way to reduce operating costs, but as a critical lever to mitigating the environmental impact of data centers and aligning with the industrial and global sustainability goals. At the Copenhagen Center of Energy Efficiency, or C2E2, we're deeply committed to driving progress in this area. We focus on advancing energy efficiency across sectors, including data centers, by identifying best practices, by promoting innovative technologies, and by fostering collaboration among key stakeholders. At C2E2, we develop tools, we provide technical assistance, we support policy and strategy development to help industry reduce the energy use and carbon emissions while ensuring the operational excellence of these centers. By leveraging our global network and expertise, we aim to enable data centers to become more sustainable and resilient in the face of these growing energy demands. And with this insight, today we delve into key strategies and innovations driving energy efficiency in data centers, including advancements in cooling technologies and sustainable operational practices. We also uncover best practices and examine how policies and regulatory frameworks are fostering these changes. By exploring these topics, we aim to highlight the importance of collaboration between industry, policymakers, and technology innovators in addressing the growing energy demands of data centers. And to unveil this, we're honored to have a distinguished panel of speakers from leading organizations, including the IEA, United for Efficiency, and the European Commission, to guide us through these key strategies, emerging trends, and collaborative opportunities in this critical area. Let me introduce you to Brendan Reidenbach, analyst at the International Energy Agency at the IEA, who will share insights into global energy consumption, trends, and data centers. Paolo Bertoldi, senior expert at the European Commission, who will discuss policies and regulatory frameworks driving efficiency in data centers. And Soledad Garcia, who is technical support and project coordinator at United for Efficiency, or U4E, who will highlight good practices, key metrics, and sustainable procurement guidelines aimed at improving energy efficiency and reducing environmental impacts in data centers. We also will dedicate the last 15 minutes after the presentations at the end of the session to a Q&A session. So please, I'll encourage you to submit your questions during the presentations using the Q&A function. And without further ado, let's start with our presentations. Let's start by setting the global context. It is my pleasure to introduce you to Brendan, who will take us through the global trends in energy consumption and efficiency for data centers to help us understand the factors driving energy demand, the challenges ahead, and also the opportunities to enhance efficiency at scale in the sector. So Brendan, the floor is yours.
Good afternoon, good morning, good evening all. Hopefully you can see my screen.
Yes, we can perfectly, and we can hear you well. Thank you.
Excellent. So to put things in context, and thank you very much for the insightful introduction, Clara, that when we talk about data centers, we're really talking about digitalization and digital services, and particularly the growth of this in recent years, looking back over the last decade, has been quite monumental. We can see that really in the last 10 years or so, we can see that internet traffic has increased 25-fold. Data center workloads have increased more than 10-fold, whilst data center energy use itself has remained relatively flat. at around 1% of global electricity consumption. And a lot of this has been down to increased energy efficiency across the whole chain through the chips themselves, the processors, but also the software that sits behind them. And as you can see that if all other sectors were able to follow this same energy efficiency gain, we'd be in a much different place than we are right now. However, we can see that even when we look at the efficiency gains in recent times, there is beginning to be a change in the total global energy consumption. And as we can see, in the last decade or so, when we look at the historical estimates that we've been tracking here at the IEA, we can see that the global energy consumption on an annualized basis is around 200 terawatt hours for the last 10 years. But from around 2020 to date, we can see that there's been an uptick in end use. So we can see that that is due to increased digital services, but also the growth of new, more energy intensive sources, such as AI, machine learning, and other advanced analytics. But what's happened here in the same time frame is that we've seen a move from traditional on-premises servers, where the servers are sat within the premises of the building, and those have been widely distributed, but rather inefficient. And in the last few years, there's been a recent response to now moving from on-premises servers to cloud hosting and co-location, but also through the hosting of services with the large hyperscaler data centers from the large ICT companies. And these have again seen additional efficiency gains due to this economy of scale of able to extract much more efficiencies by concentrating all of this compute needs together in a very concentrated location. But this has then led to increasing demands for energy for the ICT companies, as they have been able to concentrate a lot of these services in their own locations. And we can see then that over the last few years, that when just looking at the large 4 ICT companies in isolation, that their total energy demand has more than doubled in a very short period of time. And again, whilst this actually in global terms is still relatively small, when we know that data centers for the last decade or so have remained at around 1 to 1.5% of global electricity consumption. The previous situation where data centers were widely distributed across the economy had really no effect on power systems and grids. But now we're starting to see much more concentration and densification in particular hubs in Virginia, in the US, for example, or for the locations in Europe of Frankfurt, London, Amsterdam, Paris, and Dublin. And in those locations, because of the densification of that demand, this is causing localized issues, which we'll discuss in a short while. And when we look at the issues that are already being created by this concentration of services in a very specific location, there is also the emergence now of potentially increased demand. I don't think you could put your head outside the door or open up a magazine without reading an article about AI and how it's coming for all of us. But what we have seen is that when looking at the amount of energy that's needed for AI models, it is increasing. And whilst the computation input, looking at the floating points here, is not a direct proxy for energy consumption, because it's there are a lot of variables to consider because it is entirely dependent on the location of that the training is taking place and the efficiency of that particular data center. But the word exponential gets used probably quite hyperbolically in a lot of situations. But when we look at the training demand for AI, it actually is an exponential increase of energy, of computational needs. And this will only increase as these models become much more detailed and energy intense. And this will ultimately drive the need for further data centers in order to meet this demand. And one thing to clarify as well is that without going too technical into this, is that the training for these AI models it has to be a large consideration for the energy demands and the associated environmental concerns of the providing water and electricity for these training models. But the training will only be a very small proportion of the total energy consumption, because then we move to inference. So that's every time someone sends through a ChatGPT request, it might use a very small fraction of the training energy, but over the lifetime, it ultimately will be multiple factors of energy in advance of what the training energy needs will be. So, and how much this, how many times the inference will be used is unclear. And now we're approaching the area when we're looking at greater uncertainty of energy demands going forward. But with all of this interest in AI and the interest in data centers, we can see that this is translating across into the market. And looking at the US here in isolation, which is home to a lot of the ICT companies who are ultimately providing the majority of AI models and services, we can see that, again, for the last decade or so, investment decisions have been relatively flat, in line with the total global energy demands. But in the last 2 years, this has spiked up quite sharply. And again, looking at the US just in isolation, the investments made by Google, and Microsoft, and Amazon alone was equal to the total spending for the US in oil and gas. And this is around 0.5% of their total economic output in 2023. So it is rather a large area of interest for investments currently. But looking at the positioning of data centers in the wider picture, which I think is really important, because again, the media coverage would have you believe that data centers are going to be the only source of electricity in the short to medium term, which will create stresses on grids. However, when we look at the analysis that we've done here at the IEA, which considers all sectors globally, when we look at the policies that are in place by all of the governments between now and the end of this decade, we can see that data centers, which is the purple segment on the left, is actually one of the smallest areas of potential growth. And ultimately, we're going to see an increased demand for electricity in many other sectors, particularly when we look to the potential of the electrification of heating and of transport and other industries, where we can see the targets of the Paris Agreement as we look to decarbonize many of these sectors to try and offset the worst effects of climate change, that many of these other sectors really are much greater than data centers. But this isn't to deflect from the potential challenges that data centers do cause, because as I alluded to earlier, when we have moved from the situation where we had a wider distribution of smaller servers to now much more densely located units, this has created very localized issues. And within this, if we look at some of the examples we have here, and one thing to note when looking at the estimates that we have here for these selected regions, is we actually are still including very wide error bars within these when we look at the US, ranging from around 1 to over 4, nearly 5% of their national electricity consumption. The UK between 2 and 3, and the EU between 2 and 4, roughly. And one of the reasons behind this is that actually it's quite difficult to get good data on the energy consumption of data centers. And this is for a myriad of reasons in different regions as well. There is different reasons why the data is difficult to collect. But what we do know is that even within this wide range, on a national basis, these are still very small numbers to deal with, and are much smaller relative to other industries that they have there. But if we look then subnationally, if we look towards Ireland or within the US for Virginia, the picture is quite different. That when we look at Ireland, it's over 20% of total national electricity consumption is now dedicated purely to data centers. And with the majority of this demand not even distributed across Ireland, but is concentrated in or around the greater Dublin region, this does create additional pressures for dealing with the local constraints in the power grid. And similarly, in Virginia, we can see that it's over 25% now of that state electricity consumption. So looking forward then, where are we going, and what does the picture look like going further? Well, we've analyzed a wide range of scenarios or projections from various consultancies and institutions and academic studies. We can see that there is a huge diversity. And even in the US, we can see that the forecast could be anywhere between 4 and 10% of the national electricity consumption by the end of this decade. And one of the reasons it's difficult to tie down what the effects are is that using the historical averages, as we can see that efficiency gains have been so rapid to date, by using those data sets, it's not possible to forecast forward, even in a very short term. There is a great uncertainty. And so what we really need to do then is to see how can we reduce this uncertainty? How can we improve the data availability, how it's collected, but also to understand the efficiency potentials. What's best practice out there? How can we share that information, make it public on an international basis, but also what are the emerging new technologies? Much of this information is not readily available, the potential efficiency gains, and knowing what's out there would certainly be able to inform our research to have a much more detailed set of tools to make sure that our analysis is as sharp as it can be. And so with that, I'll stop there and I'll hand back to my colleagues back at UNEP.
Thank you so much, Brendan, for this very comprehensive overview of the global trends and the factors driving energy demand in the data center. It was particularly striking to see how the advancements in AI and the surging computational requirements for model training are reshaping our global energy dynamics. So thank you very much for the stage, for setting the stage and for this invaluable context. Now, with this background, let's move on to our second speaker. We now turn to the policy landscape, which, as we know, plays a pivotal role in shaping energy efficiency in data centers. It is my privilege to introduce you to Paolo Bertoldi from the European Commission. Paolo has been at the forefront of developing frameworks that drive innovation and sustainability in the energy industry industry, particularly within Europe, for many years. And in his presentation, he will delve into the policy strategies like the European Energy Efficiency Directive and the European Code of Conduct for data centers, which provide actionable guidelines for enhancing energy performance in the sector. Thank you, Paolo, for shedding light to this. The floor is yours.
Thank you, Clara, for the introduction and for the invitation. I'm going to focus more on the European Union, showing basically what is the status of current consumption, what are the policies that we have implemented in this region. So I fully support this statement of the previous speaker, who gave a very comprehensive overview. So we have efficiency improvement, which so far have balanced the large increase in demand for computation in data center and also data traffic, which is growing at a much higher level than the energy consumption. And we basically, this data also confirmed that we have a globally an increasing number of internet user, internet traffic, data center workload, and also similar activity like, for example, crypto mining energy use, which is also increasing. And similarly, not only the consumption of in data center is increasing, but also in transmission network, because all this data have to transfer back and forth from user to data center and back to the user. But today we focus just on the efficiency gains that we can achieve in data center. I confirm also that to predict the consumption is so difficult because we still have a number of legacy small data center hidden in cellar of commercial buildings, in companies, in universities, in research labs that are a bit difficult to capture. So it's easier to estimate the consumption of the larger data centers, which tend to be in the megawatt range, but when we go down to 100 kilowatt, is more difficult. And we also had a different study over the time for the EU, and almost all the study agreed in the range, but is not no one really coincided confirming the other study data. So we always talk about a range that can be in the European Union anywhere from 60 to 100 terawatt hour. And in fact, we attempted last year at the JRC to better define the consumption in Europe. We found some member states which had accurate national statistics or national data center organization which collect data. And luckily enough, these are the member states where most of the data center located, covering basically 80% of the consumption or the capacity, if you want. And then we had some assumption and modeling for the other countries. And basically you can see that we have the 8 good country collected data, then some that have partial data and some which are completely missing the data. So there is a lot of modeling to be there based basically on the number of internet user or the consumption in the service sector, and then a proportion that to data centers. And we refined this number that is a bit smaller than previous study. Of course, now the UK is not anymore with us. So it's most probably in the range from 55 to 65 terawatt hours, which is between 2 and 2.7 total energy consumption in the EU. This is basically data from 2020 to 2023. So most probably these data are already a bit larger today, that we add some new addition, in particular, as was indicated in the large data center hub, London, Amsterdam, Paris, Frankfurt, and Dublin. And very quickly, of course, the largest market is Germany due to its size, where it is about data center costs about 3.6 national use. And what is important, that we have a number of countries dominated by Ireland that last year was 18. We heard in the previous presentation now reach already 20% of total electricity consumption. So is a problem, and this translates basically in a difficulty to open a new data center unless they bring their own power, because basically there is no generation capacity, no transmission capacity to satisfy the potential demand that there is for having more data center in that region around Dublin, and the same in Netherlands, which is already very high, and Luxembourg. And most probably with all this announcement of larger data center in the range moving from typically 30 megawatt to 100, 200, and some even claiming to wanted to build a 1 gigawatt campus, the power provision to data center will be a key issue to unlock this potential development of this sector. So these slides just summarize the previous picture, showing basically in absolute value the data center consumption, and what is most important are the yellow dots showing what is representing in terms of share of total electricity consumption in the country. And we see Ireland followed by, as I said, Netherlands as the key leading country with this indicator. So what have we done to improve efficiency? And I would say that Europe, together with the United States, has been implementing policy since the early days of these sectors. In the US, it was mainly the Energy Star program. In the EU, in 2007, we decided to set up a voluntary initiative because at the time, we did not have much data on energy consumption of the sector, not much data on the possible information, the possible solutions. So we decided the best way to work was with industry, asking them to cooperate with us, being open, frank, reporting to us their consumption with the only indicators at the time we had, which was PUE, the total site energy consumption divided by AT energy consumption, give a rough idea how much was used for auxiliary services like cooling. And at the time, it emerged that almost half of the total energy going to the data center was basically to cool the data center, which was really an efficient usage of energy. And working with the industry, we come up with the idea of setting up a number of best practices that member states could implement and voluntary and reporting back to us, showing also the result of the implementation. So, and the key step was, of course, collecting the data, measuring the energy consumption of the total site, the AT part, and report annually to show progress. And already defining the PUE and agreeing on how to measure the energy consumption at the center was a big step at the time. Now it's given for granted that this is the basic for energy policy to collect reliable data. And starting from scratch, we reach about almost 600 data centers with the most important players being part of this scheme and reporting their data to us. So we have a good insight of what is going on in data center. And what we can report is that over the time, this PUE has improved, moving from an average of around 2, so very inefficient, now 1.5, with many good data centers at the 1.2 level and even below, in particular the hyperscaler that were already mentioned in the previous presentation. So just to remind, this is a voluntary initiative which has been led by the European Commission Joint Research Center, and created basically some tools for industry to benchmark themselves with this PUE, with the monitoring of the energy consumption, introduce more sophisticated metrics, and we worked together at the time with the colleague in US EPA, with colleague in Japan, with the industry, and then this PUE and other metrics like reuse energy factor or renewable energy factor were formalized and standardized by international standard bodies like IC and ISO and CENSAN in Europe. And one of the important things that we did with national government and local government, we say, okay, whenever you procure, and the government procure a lot of data center services for their salary, for their police, for their financial ministries, basically, or health ministry, whenever you procure from a public sector a data center, not just ask for service quality, price, but also include an energy efficiency requirement, which was basically to align the data center with the requirement of the code of conduct. And this was very successful in stimulating the industry to join the program, because if they want to be part of public procurement, they have to participate in the program. Another important point that we should know, and is well reflected now in policy, is that we have different type of ownership and operation data centers. So from operator to colo provider to colo customer to managed services. So not all the actors have full control of data centers. Some, like the hyperscaler, do. Some, like the colocation, are like an hotel which have the structure and then rent the space, sometimes for short time, sometimes for a long time, to many clients which bring their own servers and control basically the IT part. So there is some split incentive sometime between the who owns the infrastructure and the cooling system and power distribution, and who manage the hardware and the software in the servers. At the core, the code of conduct is a so-called best practice guidelines with over 100 best practice developed by international team of experts, which are revised every year. At the moment, we're still running with the 2024 best practice guidelines, but we are already working on the 2025 version. And it covers all the energy-related operation and dimension of data center, from energy management, from having an organization inside the company that cares for energy goal and has implemented energy policy in energy efficiency policy in the company, to the IT and software that is run on servers. And this is most probably the most critical part. We know that the IT, the hardware, tend to be efficient, in particular the processors in server or the CPUs, but the graphic units, but sometimes the software is not that effective. So we have to, in future, investigate more and try to define also methods to capture the efficiency in hardware and in software in particular, because if you do an AI task and models, and if the software is not efficiently designed, every time you run that model, you waste energy that could have been avoided. The cooling system already highlighted the importance, and we see a big transformation now with the introduction of AI, moving from the air cooling, which is not that efficient, to much more efficient system, which is based on water, being either immersion cooling or being directly the water to the chips. And in fact, most probably, very powerful AI data center will revolutionize the cooling system, really moving to water cooling. Then to other equipment like UPS, like pumps, like ventilators, like lighting. And the emphasis always also on monitoring and reporting the different KPIs in a data center. This is an example, for example, from the best practice for the cooling, starting from very basic rules like separation of cold and hot air to more sophisticated recommendation, in particular, wherever possible, use free cooling. And this is again gaining importance, in particular in the northern part of Europe. Now all the data centers are almost running all the year round with free cooling, meaning avoiding using compressed air cooled by a compressor in a chiller. Another policy initiative is related to the EU taxonomy regulation and is introduced with the delegated act. Basically, the taxonomy defines when an activity, particularly financial investment in a company, is sustainable and according to ESG, and can be classified as climate friendly, in this case, in the domain of the climate mitigation and climate adaptation. And the criteria that has been selected, the taxonomy cover all of course, the sectors of our economy, including data centers, and basically set as criteria for fulfilling the taxonomy requirement to implement all the best practices of the code of conduct or equivalent standard, for example, like the maturity model developed by SEN. And this fulfillment of the best practice of the code of conduct should be verified by the independent third party. And we worked last year to publish an assessment framework for data centers, basically translating the best practice into an auditing procedures that independent auditor can carry out in data center. And we see a growing interest for company because they have to report their investment according to the non-financial disclosure reporting requirement, their investment, and they're very much keen in reporting as aligned with the climate change mitigation principle of the taxonomy. And finally, most probably the biggest revolution in policy in this sector and most probably an innovative policy for globally is the work carried out by my colleague De Jenner in the frame of the Energy Efficiency Directive, which was revised, and the revise was adopted by Council and Parliament in 2023, where under Article 12 of the recast Energy Efficiency Directive, there was basically to introduce the idea of having some mandatory reporting of data center operators to collect data, and then with this data establish some key performance indicators, and also enabling then the Commission to further elaborate policy once the data have been collected. As an analogy, whenever you do standards, for example, for refrigerators or for any other product, there is a lot of data there which you can buy from company telling you the sales in terms of A to G classes. So it's easy, you can calculate how many efficient, non-efficient refrigerators are sold, what are the costs, and you can then regulate it. Data center is so complex, they say, and still after some years of operation of the code economy, we have reached only a fraction of the total amount of data centers that data is dramatically needed by policymakers to make then effective policy. So basically what the ED did was to set up a frame for collecting data from data center, ranging from floor area, installed power, annual data traffic, data operation, as well as temperature and power going to the IT systems. And following this initial requirement in DD, the Commission adopted under the so-called delegated regulation, which has been published in May this year and entered in force, which basically established the first phase of a common rating scheme for data centers, and basically is define the reporting requirement that were introduced in the ED, listing all the measurement data that have been submitted regularly by data center operator with installed IT power demand above 500 kW, and together with other important indicators. Of course, the physical dimension data center, the STT capacity, and data traffic, the energy consumption of the total data center, of the IT part, and then of the share of renewable that is supplied to the data center, or the purchase of green certificate, and the wasted reuse. And this is an important point that often is forgotten. Due to this vast generation of heat by the processors, there's always an excess of the need to evacuate this heat from the server room, and traditionally this heat was wasted in the atmosphere, in heat exchanger or cooling tower or whatever, and this waste in a lot of situations can be recuperated, reused, shared, for example, with buildings, so district heating, district network to greenhouse nearby, and so it's very important. And finally, these directives set up some important indicators to be reported. Reported is annual. Let's say the first cycle was due of reporting was due in September this year, and then will be in middle of May every subsequent year. And there is both a database for reporting at European level, as well as in some member states and national level. Of course, this is a policy that has been designed and is operated by my colleague De Jenner, and on their website you find more information on the scheme, the obligation, and of course also the ED and the delegated act text. And with this, I think I overused my time, so I would like to thank you for your attention. I hope that my information has been clear. And if not, you can always contact me. And for more information on the UDC Code of Conduct, you can visit the website there. As I said, for the ED and Delegated Act, you can visit the DGNR website. Thank you very much.
Thank you so much, Paolo, for providing this valuable insights into the policy landscape with particular focus on Europe. It's really impressive to see the extensive research and the analysis that has been undertaken by the European Commission to really improve this assessment and regulation, because as you said, without data, without insights, we cannot have effective policy instruments. So yeah, we see that the EU continues to lead the way with initiatives such as the Energy Efficiency Directive and the Data Center Code of Conduct, which prioritize transparency, best practices, and sustainability metrics to mitigate the environmental impact of data centers. Thank you very much. And talking about best practices and metrics, I would like to introduce you to our third and last speaker, Soledad Garcia, who will discuss the key strategies to enhance energy efficiency in data centers, focusing on guidelines for sustainable public procurement and best practices to reduce environmental impacts. She will address critical challenges like the energy and water usage in the data centers, as we have seen today. It's a very critical aspect of our data centers, and she will propose solutions such as adopting advanced cooling technologies and resource-efficient designs to highlight how these efforts can really drive a sustainable transformation of the digital infrastructure in globally all markets. With this being said, over to you, Soledad. Thank you for joining us today.
Thank you very much, Clara. Hello to everyone. Joining me, it's my colleague, Bruno Lafitte. We are both part of the U4E team. So next slide, please. So to start the presentation, I would like to highlight some of the challenges on the sustainable side from data centers. As we saw in the previous presentations, clearly data centers are extremely energy intensive facilities, and therefore they have a sizable carbon footprint. So on the one hand, the data center is characterized on its IT installed power. So the primary energy consumption is the electricity that is required to run the IT equipment itself. And this is typically accounting around 40 to 70% of the total energy use. In addition, since the servers operate 24/7 and they consume electricity power both in the active and a passive mode, they require of an alternative power supply to continue the operation during power outages. So this means that they increase the electricity consumption, the cost, and therefore the CO2 emissions. And this is especially the case for the data centers that are located maybe in countries that doesn't have a stable electricity power supply. So this is like an added problematic. Here are some figures on the size of the issue on the electricity consumption that have already been explained, but maybe I would like to highlight the last one. This is an IE figure that states the data centers consume an estimated of 460 terawatts in 2022, and this is equivalent to 2% of the global electricity consumption. So next slide, please. Thank you. So all this electricity that is consumed by the servers and the storage devices are converted into heat. This was just mentioned by Paolo. So the heat is coming from the servers mainly. This is 90%, and the rest is by other elements. And all this heat has to be removed from the data centers to avoid it that the data centers are damaged and also to damage the equipment. And this is done through different cooling systems. The cooling systems consume, therefore, additional energy. And this accounts between 20 and 50%. And in some cases can even exceed the ICT equipment consumption itself. So, and in addition, the cooling systems also produce additional heat, which is mainly coming from the compressors of the air conditioners or the heat pumps. Therefore, here we have a huge chunk of the electricity that is consumed. And therefore the selection of the cooling system is key. Not only because of the level of the electricity that I mentioned, which is huge, but also because depending on the cooling system, it can require a lot or important access to abundant and secure water. This can be the case, for example, of adiabatic or evaporative cooling. So this is something to also take into consideration because it can be very challenging for countries where water is scarce. And therefore, here we have another challenge. And the last one that I wanted to point out is because of the huge amount of electricity that is required, is critical that we shift the power consumption from fossil fuels to renewable energy. And this is clear. But on the other hand, it's important that the production of this green energy that's coming from a country, it's not monopolized by data centers operators. And that the owners of the data centers are both tenants and developers of renewable energy projects. Next slide, please. Thank you. So against this background, it's very clear that data centers have to be regulated, that it's imperative to make them and the computer servers more energy efficient to reduce their impact in the environment. And therefore, here are some benefits. First and foremost, the reduction of the energy consumption. This is clear. The reduction of the water usage, the expansion of the internet access, and I will come back to this in a second. The increase of the use of renewable energy to foster waste heat use. This is by selecting the appropriate cooling technologies and providing the right incentives. Lowering the material impact by increasing the utilization rate of the server. Because as we increase the utilization rate of the server, therefore we require less number of servers, obviously. And last but not least, the control of the country's development by lowering the impact of the data center on the electricity grid and water supply. Next slide, please. In the previous slide, I mentioned about expansion of access, and this is because Paolo mentioned in his presentation, currently most of the data centers and the co-location data centers are located in developed countries. We mentioned the US, Ireland, the Netherlands, so on and so forth, but the number of data centers in emerging economies is also growing rapidly, because of the economic growth that it's linked to the increase of demand for data, the growing demand of sovereignty in data processing and storage, but also because of a matter of price. Here are just a few figures, such as in Asia Pacific region, the data centers are expected to double to 2025, or the fact, for example, that in Africa, the price of the exchange of the data could be 5 times in Southern Africa compared to the US. So the gap can be huge. In South America, the data centers are also expanding, and at the moment there are more than 120 data centers, and more than half are located in Brazil. Chile is also championing this evolving market. So all in all, data centers are expanding in emerging economies as well. Next slide, please. So against this background, and also to address the sustainability issues that I mentioned at the beginning, it's clear that it requires the effort from the private and the public sector. The private sector, we understand, it's championing the innovations from the sector, it's pushing the technological limits, but on the public side, it's also key, because the governments play a key role in the definition of the standards and the laws and the guidelines on the one hand, but also on enabling buyers to propose innovative solutions that meet certain criteria. So This is the case, for example, when a country is going through the selection and approval of, for example, where to host their data, the selection of a co-location data centers, for instance, or secondly, when they have to approve a proposal for building a new data center. So we, from View4E, we have developed a green public procurement technical guideline for data centers and computer servers with technical recommendations and best practice recommendations that should be considered during any SPP process. So this guideline is mainly aimed for developing economies that may not have a regulation to reference, a regulation on their own, of course, and whose data center markets are just emerging. So the guideline provides technical recommendations in a very straight and easy forward way. Next slide, please. And here a quick glimpse of the scope of the content of the guideline. As you can see, we have selected a number of performance criteria and operating conditions that we consider that are the most relevant and impactful for the selection of an energy efficiency data center and computer servers. The recommendations revolve around very well-known KPI, the power usage effectiveness, for example, the PUE, but not only. We are also providing recommendations on water usage effectiveness, the cooling effectiveness ratio, the IT equipment energy efficiency for servers, the server's efficiency, the data storage efficiency, the power supply efficiency, and idle state efficiency. And on the other hand, with the operating conditions, we have provided recommendations on the location of the data center, the renewable energy factor, the resilience of the data centers, modularity aspects, cooling design, operating temperature and humidity range for servers, CPU power management criteria, and the utilization rate of the IT equipment. As you can see, these are all very well-known KPI, and all the recommendations are based on international best practices and regulations that are already available. But just to highlight that these criteria are not the only one that define data centers, that there are other aspects that could be considered, but in the guideline we have made a focus on these ones because we consider are the most relevant ones. Next slide, please. So for each criteria that I mentioned before, sorry, we provide the definition, the equations, the overall explanation, and the measurement methods, and of course the recommended values. So as to provide a reference for the public procurers so they can equally assess the data center through a typical tender process. The definition of all these values is the result of a participatory process with many organizations, international organizations such as the Green Grid, Uptime, but also with service providers. We have tried to channel the voices from different organizations and also from the private sector. Here, just to give you an example of the KPI values, as you can see, we have provided values for both the existing co-location data centers and also for new buildings, for new data center buildings. And within this sector, this segment of new buildings, we have also provided values after the ramp-up period. So we have both the by design values and after 3 years of operation in order to reflect improvement of the cooling and operative system performance as you are filling the facility with more servers and have more clients, so on and so forth. So another important aspect is that some KPI can be dependent on the temperature of the region where the data center is located. and therefore we have provided specific values for hot and humid climate as per the dry climate zones. And therefore, for example, the PUE, you can see one value and another one below that says HH. So for us was very important to make that differentiation as well, because of course, with a warmer climate, you have more electricity to cool it and so on and so forth. So there's a huge difference. And another aspect is because we expect that the technology keeps on advancing, values start in 2025 and progressively increase to 2031. And maybe just one last thing from this slide is that I wanted to highlight the values recommended on PUE, because usually there's a trade-off between water and power consumption, depending on the cooling technology used. So, for example, for adiabatic cooling, which consumes a lot of water, this is often used actually to reduce the PUE. So somehow the PUE and the WUE are inversely proportionate, right? But we have taken this into account, and we have considered that these PUE values are achievable together with the WUE values. So, yes, next slide, please. Okay, so something that I want to highlight is that we do not suggest banning any technology, and we do not advocate for any particular technology as part of the recommendations, because we understand that this depends on multiple factors, such as the priority from each country / customer, where it's located, the climate conditions, and many others. So with these guidelines, we want to just push for the energy efficiency optimal levels. And being this said, we envision the recommendations in the guideline to be applied depending on two scenarios when it comes to the tender process. The first scenario is for those countries that have a public authority that specifies a minimum performance threshold that the offer has to meet to be eligible. And once that offer meets the minimum, then it's chosen based on the price. If this is the system, the tender process that the country goes through, then we recommend that the minimum performance values are the ones that we indicate in the guideline. But for other countries, the performance of the offers can surpass the minimum value. And then it makes a competitive situation between the offers. So in that case, the policymakers can implement an award criteria system to define which of the offers is the best choice. And also with this award criteria, we go back a little bit to the aspect of the country's different priorities. So this is why this weighting system can capture the priorities of and the situation of each tender. So yeah, this is just one aspect that it's different from the code of conduct. So all in all, the public authority can tailor the weighting values and award different points depending on the country's priorities. And of course, the levels that are on the top, I mean, the top values that we indicate in the award criteria would be matching the best practices possible. The next slide, please. And just to finalize the presentation, and since cooling represents such a central topic from the data centers, we wanted to compile some of the best practices that are also captured in the guideline to reduce their impact. So for instance, to increase the temperature operating range of the server, The second one, the IT design to cool only the server and not the entire IT room. Therefore, the IT room structure should be modular. So, as you know, data centers operation change over time. New servers might be added because of the business growth. So it's important that the data center can adapt to these changes and save energy because of the cooling. Incorporating this modular room designs to adapt to the cooling needs. So we think this is a very important aspect. The third one is to increase the efficiency of the existing cooling system, mostly air conditioning. Fourth one, to change the cooling system to liquid cooling, if relevant. Once again, we're not advocating for any specific cooling technology because this depends on the application and the specific situation. But this can be very relevant in many cases. For example, when we have high power density data centers, and especially for IE applications. The next one, change the refrigerant to one with a low global warming potential. We recommend that the GWP of the refrigerant used in data center cooling equipment should be lower than 10. And for air conditioning equipment, it should be lower than 680, just to have an idea. The sixth one, the increase of the use of free cooling or chilling with efficiency fans. And last but not least, pumps, and compressors should be monitored. It should use very efficient motors, IE4, IE5, or NEMA's super premium electric motors, and also to incorporate variable frequency or speed controls. So this is just very quickly a flavor of the content of the guideline. In there, you will find all the details for each of the parameters, for each of the criteria that I mentioned before. So I really encourage you to have a look to explore all the recommendations in detail. And the guideline will be available by the end of the month from U4E's website, so stay tuned. So I think that's all from my side, and thank you very much, Clara, for the space to present this.
Thank you so much, Soledad, for being with us. I'm presenting this very highly valuable guidelines that, as Soledad said, stay tuned for the United for Efficiency website to make sure that you get the guidelines as soon as possible. We're running a bit over time. We have run a bit over time. We're trying to reserve at least 10 to 15 minutes to our Q&A session. It won't be possible, but I just want to share one question from the audience. Please, speakers, if you could all turn on your cameras and your audios to receive this question that we will address very quickly, just to not run too much over time. Thank you, Brenda. Thank you, Paolo. Thank you, Soledad. We had this question from the audience. We have many others, but unfortunately we had to select only one. Do you have any benchmarks for energy consumptions of data centers set kilowatt hour per square meter?
If I may start, that is a difficult question because depends on the type of process. I mean, typically in a square meter is a rack, vertical rack with about 5 to 10 servers inside. Each server is usually about 500 watt to 1 kilowatt. So we're talking between maybe 1 to 5 kilowatt hour. But this is not indication of consumption, not indication of efficiency. But then when we move it to AI, this rack will be 50 kilowatt. So much more intensive use, but could be more efficient because it needs to be water cooled. The air cooling won't work anymore with such power densities. So this is in my short reply.
That's brilliant. Thank you, Paolo. Very clear, and good to have also the reference of AI as well. Thank you so much. What about you, Brendan? What's your assessment from the IA side?
Again, I think trying to pin down an exact number is not going to be possible. It's not a precise science. It's not like trying to make a kilogram of steel or a cubic meter of concrete. We know we've got the empirical data that we can use for those numbers. I think the challenge is, I alluded to it in my intervention earlier on, is that using historical data isn't useful for doing future projections. And another challenge is that data and energy are not directly linearly related. So like an exponential increase of data needs doesn't automatically translate into an increase in energy consumption, because there's so many multiple factors: the cooling, the lighting, just the running of the background services, etc. So it's a very difficult area to get really precise figures.
Your audience really pinpointed at one of the weak spots when it comes to data for data centers, or especially when looking at the energy side. Thank you so much. Soledad or Bruno, do you want to also comment on this question?
Well, sorry, Soledad. Just for data, this is Bruno Lafitte, and well, you didn't see me before, but my name was in the presentation before. Yes, for data, we have a lack of data. That's for sure. But now we will have data because of this European directive, and we are gathering data. All state members are now gathering data, and there will be a report coming from the Commission that will be released by May or June, and we will have a lot of data on big data centers for more than 500 kilowatt. But yeah, that would be very useful. And for density, I agree with Paolo. Now we move from density for rack, which is typically 2 kilowatts to 50 or 100 kilowatts even for the artificial intelligence. So there's a big gap, and there's a revolution that is going on right now.
Brilliant. Thank you for this response. And again, stay tuned. Another report to publication to look towards June, you said, right, Bruno? I believe, or I guess Paolo will also be aware of. So once again, great job that the European Commission is doing in terms of really shedding light into the understanding of what data center energy consumption is. So thank you very much, Paolo, for that work and that push ahead. Unfortunately, we do not have time we're already 8 minutes over the initial schedule of this webinar, so we won't have time to address any further questions. Apologies in advance. But I do want to thank all of you that have attended this webinar, and also to our incredible panel of speakers, Brendan, Paolo, Soledad, and Bruno, for their insightful presentations, answers throughout the session. Thank you very much. And I look forward to continuing the conversations on this critical topic on energy efficiency in data to achieve our sustainability goals. Looking ahead, I think one of the things that I identified as key, at least, was the collaboration, which will be key. I encourage all of us to engage with all of the community to make sure that we are informed of what the energy consumption is for data centers, but also what the energy efficiency opportunities are in the sector. I also want to thank my team here at UNEP CCC, Aristides and Trupti, who have made this possible. And thank you everyone again who joined us today. We hope you found this session informative and inspiring, and I wish you a great day ahead. Thank you very much.